This is the inside of a turbine that powered our exciter generator in the other room. We are now in the turbine room. There are 6 turbines here, 2 small and 4 large. You can see up above at the top of the turbine room that the water came from the forebay down these giant penstocks. This one is 8 feet in diameter and into a giant turbine. There are 2 wheels, one on each side of the turbine. When the water ran through them, it turned a shaft which went into the other room to power our massive generators. Each one of these shafts generates 1,250 horsepower when it's in operation. And again, the smaller turbines with the smaller penstocks had to power the exciter motors, the direct current generators in the generator room that powered the electromagnets in the big AC generators. This is a Francis-style turbine used for low-head applications. We only had about 57 feet of head in these turbines. They're bronze, and as you can see, there was one on this side and one on the other side of the turbine.
To start up the powerhouse, the operator would first need to turn this wheel, would open up the vanes inside the smaller turbine and give power to our exciter generator right here. This is a direct current generator, and it supplied power to the large alternating current generators. The electromagnets are in an array all the way around the outside of the power plant here, and then you needed to turn the wheel on the governor to start the shaft of the big alternating current generator to create alternating current. And here is the wheel for the governor, right here. The governor was required to make sure that the shaft ran at 300 RPM. At that speed, exactly, you would get 60 cycle alternating current from the generator. The advantage of alternating current over direct current is that it can be run through transformers to raise the voltage way up high. With high pressure and high voltage, you can run current long distance. Here, it had to go 22 miles to downtown Sacramento. So these transformers and the air-cooled ones upstairs were capable of increasing the voltage from 800 volts up to 11,000 volts.
So how does this control panel control the whole power plant?
Well, we must remember that if you're going to run this power plant 24 hours a day, that you need 3 shifts of 3 operators at least to operate the powerhouse. Once you've turned on the large turbines through the governors, all the power comes to this control panel. And here is one of the main switches for one generator. And you can see there are 4 switches to control each one of the generators. One of the important things that had to be done is that all this power had to be in sync. And so the addition of a synchroscope on the far end of the control panel helped and made it easier to get the waves all lined up so that they could run down one set of wires to Sacramento.